Hey, should we get started then?
Yeah, absolutely.
Okay. I guess I will share up the presentation that we have first. Um, so I wanted to welcome everyone to our third virtual conference. So very exciting. Thank you for being here, even though there's hockey on. Um, So these conferences are a great way to stay engaged with the community, especially for those that are unable to attend our in-person conference. So before we begin, I would like to share a little bit about myself and sort of recognize the ancestral history of Canada. And so my name is Christie Cruz. I use she, her pronouns. I actually grew up on the border between Alberta and Saskatchewan, but I'm currently a master's student at the University of Ottawa with Julie Lee Yaw. And so I want to pay my respects to the First Nations, Inuit, and Métis people of Canada and acknowledge that I currently reside on unceded Anishinaabe Algonquin territory. So today we are meeting virtually coast to coast across Canada, and I encourage everyone to think about the land they're on, wherever they are, and think about how to incorporate Indigenous voices and knowledge into our work. As herpetologists, our natural lands are so important, and the animals within them as well are so important to us. And so this recognition is a renewal of our commitment as a society to listening to and cherishing the traditional knowledge of Indigenous people. And I also want to welcome any international participants we have today and the experience and heritage they bring with them. And so now I'll take a few minutes here to briefly go over some slides, just to start everything off. As I find things. So here's the CHS code of contact, just to keep this in mind while we are doing the conference here. Um, and then just to remind us and introduce some others to the Zoom functions that we might be able to use. And we are happy to see your faces if you are willing and able, so you can turn your video on and off if you would like. If you would like to ask questions, you can either react, you can also raise your hand or put a question in the chat. Here is a brief look at the sort of the agenda that we have coming up, and this will be the lightning presentations. And then I did also want to rep our blog here, which is The Drift Fence. So if there's anything that you're interested in writing a little blog post about, please do. Also, we have a little publication called The Canadian Herpetologist. I believe volume 15 just came out, but it's a great place for little natural history notes, anything of interest. So definitely look into doing something with that. Also, we have a YouTube page where our past virtual conferences have been recorded and posted, and so will these ones. And then we have a bunch of committees. If anyone is interested in joining, we could always use the help. So definitely, please think about it. And then a thank you to, of course, the Meetings and Workshops Committee and all of the effort that they put in to help organize both this conference, the past conferences, and upcoming conferences as well, which includes the 2026 annual conference, which will be in PEI. So please save the date. That's September 18th to 21st, 2026. And I'm really excited. I think it's going to be great. So we'll stop sharing. So now we should be able to get started. So we are going to have 9 talks over the next like 2.5 hours or so. There'll be time for questions at the end of each talk, and we will take a break at the halfway point. So for presenters, reminder that you have 12 minutes to present with 3 minutes of questions. I'll be setting the timer, and we'll interrupt you if you get to the end of your time. So I believe to start, we have Steph will be first. So if you'd like to share your screen.
Thank you so much. Can you hear me okay? And am I sharing okay?
Yes, you're good. And can you see the timer up in the corner okay?
I can.
Perfect.
Perfect.
All right.
All right. Hello. Thank you so much for having me at the conference. It's a bit of a thrill of mine to be amongst esteemed colleagues. My name is Steph Kohout. I'm a part-time JD or law student. I'm at Osgoode Hall Law School at York University. I'm doing an independent research paper this semester, and I decided to bring some of my interests together, and they managed to intersect with turtles and with you herpetologists. So super cool. My presentation is called In Search of Safety Nets. It's legal research on species at risk protections for turtles in Ontario. Just a brief land acknowledgement. Thank you so much, Christie, for the land acknowledgement at the beginning. Since I'm coming to you from Toronto, I did want to acknowledge the traditional territory, including of the Massasaugas of the Credit, the Anishinaabeg, Chippewa, Haudenosaunee, and Wendat peoples, from where I'm coming from. And this territory is also covered by Treaty 13 and the Williams Treaties. I acknowledge that I benefit from the ongoing colonial forces that exclude these nations from their territories. I seek to understand this better and what actions I can best take to address this. And I'm also looking for ways to reconnect with the land and its inhabitants, human and non-human, and for ways that all can exist together in a good way. So just before I begin, one other housekeeping thing, a little bit of a disclaimer. I'm not a lawyer, I'm a law student, so don't take anything I say as any sort of legal opinion. Talk to your qualified local legal professional for legal advice. My other disclaimer is I'm a neophyte. I'm new to law, and I'm also new to herpetology and turtles. You all are the experts. Many of you have spent your life in this field, probably, and know more about both the law and turtles than I do. So please help me to complete my understanding. I welcome any of your guidance, feedback, challenges, etc. Just a little background about me. We were very lucky from our Toronto home to buy a small parcel of land in Haliburton, where we have a little bunkie. Along the way, we would stop and help herd turtles by the side of the road, which I'd rarely seen before, and started to get a bit more informed about the situation of turtles as species at risk and learn about their importance in things like biodiversity as well. This intersected well with me with some of my interests in law school, which include Indigenous law, Aboriginal law, environmental law, and conservancy. And I reached out to some ENGOs that are working in Haliburton, or also known as the Land Between, around turtle conservancy, and just seeing if any of my legal studies could be of actual practical value to any of the turtle conservancy work that was going on. I have gotten guidance from some ENGOs, and I hope that some of my research that I'm going over today could be of some usefulness. Where I'd like to take you today on the roadmap, I talk a little bit about species at risk legislation protections from my research, mainly in Ontario, but also federally. And research question 2, a case study in trying to do a SARA Section 80 emergency order. So for my research question number 1 is basically what are current and future protection for Ontario turtles and habitat through species and risk legislation, which devolves into a number of sub-questions that I'll get into. For this research, I looked at some background legislative frameworks, including United Nations Convention on Biological Diversity, the Accord for the Protection of Species at Risk, of course, the Species at Risk Act federally, the Endangered Species Act, and the Species Conservation Act here provincially in Ontario. All of them contained many of the themes, prominent themes of environmental law, such as the precautionary principle. My analysis really centered on I wanted to understand better the shifting landscape of the Endangered Species Act here in Ontario, since it's undergoing a lot of changes. The ESA in its earliest form was enshrined in 1971 and was quite a golden standard for species at risk legislation. That got modernized into the Endangered Species Act in Ontario in 2007, which on paper had a lot of protections for species at risk. Over time, though, as many know, that Endangered Species Act was amended many times, and through other problematic avenues like lack of enforcement, a lot of those initial protections have been watered down. My key takeaway from the provincial scene is that the protections are currently minimal and overall diminishing. Just moving from left to right, in the grayed out box from the Endangered Species Act of 2007, in its last incarnation, previous to the current one, from 2024 to 2025, we have a number of different protections on a number of different axes, and these are just highlights. Harm to species at risk was prohibited, including harassment. Residence and critical habitat was protected. Recovery strategies were required. Permits were required, and special concern species were listed. Unfortunately, as of June 5th, 2025, that Endangered Species Act was amended into its latest incarnation, and harassment was taken out, as well as critical habitat protection and recovery strategies no longer required, amongst other watering down of protections. The Species Conservation Act is yet to come into force, but it is imminent, and this further waters down protection for species at risk, moving to a registration first system in which permits are still required for some activities, but mainly on the basis of registration. Harm to species at risk can go ahead, as well special concern species are no longer listed. This is in contrast to the federal scene, which the Species at Risk Act from 2002 enshrines, which has a number of good protections that were emblematic of the original Endangered Species Act. However, sadly, SAR only applies to federal lands. When looking at Ontario turtles, federal lands are probably 5 to 10% of the land mass in Ontario. So for the vast majority of land in Ontario, SARA is not applicable. However, as many know, there are provisions within SARA that allow SARA's protections to be applied to provincial lands, including Section 34, Section 61, and Section 80, the emergency order. While this gives some hope on paper, in practice, the scene is disappointing, as these safety net orders are rarely made. In my research, I've found no enactment of the Section 34 order, nor the Section 61 order. There have been 3 emergency orders for Section 80, and that does give a little bit of hope. However, overall, as many know, the scene is littered with case law from litigation of groups that are trying to get the federal government to live up to the mandate of SARA, but due to recalcitrance and due to delay and lack of resources, it's very difficult for the federal government to live up to the SARA mandate. We have some recent examples now of the new caribou litigation that just got launched, as well as the denial of the Orca order in 2025, as more examples of the difficulties with SARA. However, there is one small little success of the Western chorus frog in Montreal. There was a successful emergency order there, and that emergency order actually has some teeth. There was some charges for contravention of the order, and the order actually applies to private lands, not just commercial, residential, or public lands. So in the rare occasion where a Section 80 order is made, it does actually have some teeth to it. That all brings me to my second research question was it or is it viable to pursue a Section 80 emergency order for turtles in the Haliburton area, which I am connected to, or also known as the land between, in light of the repeal amendment of the Endangered Species Act? This land between, of course, being vital. It has been nominated for an Empire designation and is the stronghold for some turtle species, known also as the last intact wilderness expanse of southern Ontario. So taking that question into kind of a case study, my research is drilling down into some questions. For instance, is continuing and intensifying road network, and commercial residential development sufficiently imminent and extreme enough for a Section 80 order? What's the impact of trying to request an impact threat assessment first versus an emergency order? I'm also interested in the recovery strategy for SARA for blandings. The main strategy that is being impacted is law and policy by the repeal of the ESA. So what's the significance of that? As I wrestle with these questions into my research and into my final paper over the springtime, I'm at an inflection point and I welcome any feedback. I could keep my original scope and keep scoping an impact threat assessment and a Section 80 emergency order for turtles in the land between, but is it imminent and extreme enough and warranted? I could try to move the scope. I've been suggested with the ENGO that I'm working with that perhaps a more imminent threat is Highway 413, which is being built on the borderlands of the land between or below the borderlands. And there's also an emergency order that's already been made there for the red side dace. Perhaps that's a more imminent threat and could have more impact there. I could look to, oh goodness, I'm sorry. I could look to enlarge the scope as well and look at other statutes and agreements, such as the Ontario Fish and Wildlife Conservation Act. As has been suggested by the ENGO, there are some protections for fish there that could be extended perhaps to turtles through a kind of novel interpretation. Or this one lights my fire. try to reframe the whole thing. Could there be a successful Section 7 charter challenge that there is, in fact, a threat to the security of the person, of people living in Ontario from the loss of biodiversity from the repeal of the Endangered Species Act? I welcome any and all feedback in our questions. And just before, a little bit of a plug, law student research. We are looking at setting up some research-a-thons at Osgoode through some of the Animal Justice and Environmental Law Society clubs. We're going to work with FLAP Canada, hopefully, to address some legal research that they would like more insight into. If that's something that could be helpful, feel free to reach out. And otherwise, I want to say thank you so much for having me here today. I wish you all luck with your very important work, and us in the legal community are rooting you on. Thank you.
Excellent. Very interesting. I'm excited. Does anybody have any questions?
There aren't any questions in the chat, just an FYI.
I'd be happy to take, if anybody wants to have an offline conversation specifically about 413 habitat and how that could affect turtles, or anywhere else an emergency order under Section 80 could be of interest, or an impact threat assessment. I would love to put some of this research into action and actually help turtles and the Turtle Conservancy community. So feel free to reach out with any brainstorm ideas afterwards. Otherwise, again, thank you very much.
We actually have a few different minutes for, like, we have about 5 minutes for if anyone has anything of interest or any comments even, before we get to our next presentation.
We did see one chat question there. What is the mechanism for a special order? Great question. So the legislation of the Species at Risk Act from 2002 federal has three different provisions that I found so far in which a special order can be made. One can extend protections for prohibitions on harm. Another can extend protections on critical habitat. That one, unfortunately, needs to be made by a provincial minister or one of the scientific bodies attached to SARA or ECCC. The Section 80 is probably the most impactful one. Looks like anybody, to get a Section 80, as I understand it, you need an impact threat assessment or it's recommended, and anybody can make a request for an impact threat assessment. There's policy guidelines that are posted on the web about how to request one and the information that's needed. Once one is submitted, then it's assessed. And I think on the basis of that, that gets the designation of the imminent threat. Once there is the designation of the imminent threat, it goes to the minister. And if the minister agrees there is an imminent threat, thank you, they must make a recommendation to Governor and Council, which is Cabinet, to make an order to extend emergency protection to habitat and that species. That's the point at which things tend to fail, is that one, the minister may not make the opinion that there is an imminent threat. And secondly, even if it's recommended to Governor and Council, which is Cabinet, Cabinet may decline to make an order. And then even to get to the point of the minister to form an opinion that there is an imminent threat, there seem to be interminable delays, which has given rise to many lawsuits to try to force the government to get to the minister's recommendation. Yeah, I hope that answers your question, Jess. Feel free to, you're welcome. Feel free to follow up offline if you'd like.
And there's a few comments about enjoying the presentation and good work, and I would second that.
Thank you so much. I really appreciate it.
This is Roger, just following the chat.
Okay, well, if we don't have any other questions, I suppose we can move on a little bit early to Kari, I believe. You're up next.
All right, can you hear me? Great, that's a good start. I'm going to share my screen. Did it share?
Not yet.
Okay, hold on.
There we go. You're sharing now.
Yeah. Does that work? Okay, great. And the timer
Timer
is
is up.
at the top. Okay. All right. Okay, hi everybody who doesn't know me. I'm Kari Gunson, and I'm self-employed for EcoCare International with EcoCare and based in Peterborough, Ontario. And I solely do road ecology work, mostly applied mitigation, and a lot of reptile work in Ontario, especially with the Endangered Species Act that created a lot of work. However, that might not happen in the near future, as we heard. We all know that reptiles are one of the most endangered group of vertebrates on Earth. In Canada, it's the most endangered, and road mortality is a top threat. Talked about road mortality and fragmentation of roads between nesting habitat and wetland habitat is a big one. So wetland to the upland habitat movements. Predation is huge, especially along roads. You can see this raccoon getting the eggs where a turtle just nested up along a road. And loss of nesting habitat, of course. So we're trying to create nesting habitat, which I'll talk about along roads so they don't nest along the roads. So there's 3 components that we try and implement to help these animals in our key crossing spots from wetland to dry upland habitat. And that is crossing structures, if indeed they need to cross the road to get to that nesting habitat, exclusion directional fencing to guide them to that crossing structure or to keep them off the road. And then, of course, creating habitat, which I've talked about. For turtles would be nesting habitat, and for snakes would be hibernaculum. We're going to talk about 3 specific projects really quickly because we don't have enough time to go in any further, but I do have reports or write-ups or additional materials on all of these projects. So please reach out. And all of them happen to be on the Great Lakes where we have a lot of our freshwater turtle species. So the first one would be Port Franks on Lake Huron. And this one actually was quite a while ago in 2014, I believe. When it started, it was a road upgrade. And this is something to take advantage of when you see things like this happening. And this is when you contact your local municipality or your conservation authority. They were replacing a guide rail here that you can see, and the new wooden posts in the ground. So the conservation authority took the opportunity to use Animex fencing, HDPE, and get the sheets custom made and bolted onto those wood posts and a trench at the bottom to keep the fence buried. And they also took advantage of an existing submerged drainage culvert on site. And there was speculation whether or not turtles would use that culvert, mainly because there was water in it and things like that. But lo and behold, 2 years of monitoring showed all 4 species, actually 5 species, spotted turtles and blandings included, musk, painted, and snapping turtles going through. We have confirmed crosses, and these are pictures of those turtles going through, coming in, blandings turtle at the bottom left. And I'll leave it at that. And we'll move on to Kingston, Ontario. So this project was another development and taking advantage of that development to wrap fencing around a wetland, separating the new construction from the wetland in the top left there, and also adding in new crossing structures for connectivity and using existing structures. And there was a loss of nesting habitat with exclusion fencing because they previously nested on the roadside. So we needed to create some nesting habitat. And creating nesting habitat that works for turtles is a new science in the province. And so we went to work to try and set out and do effective nesting habitat. So we ended up, after many, many reviews and debates about whether it should be on private property and getting permission or on the city property. And we ended up only having the permission of putting them on the city property. So they were abutted up against the fence in that property zone. And they also were in wetlands because the wetland abutted up right to the right of way. So we needed to raise them up. And to do that, we put in, I'll show you in the next slide, some riverstone rock to keep them up. But the advantage of that was that the turtles, the emerging hatchlings, could just roll down that slope right into the water. So I talked about crossing structures at this site, and we put in an ACO open top tunnel adjacent to a drainage culvert. The drainage culvert had more use of turtles going through simply because it was along the drainage and the movement path of the turtles. So very important to keep that functional. And we actually ended up being able to upsize that. And they had poured riprap around that drainage culvert, which was a no-no. So we got that riprap removed and we put smaller pebbles and rocks, river rocks in there to make it easier for the turtles to use. And this shows you the nest mound construction. Here we show that they cleared the veg, then they put in the riverstone rock to raise it up. And then the substrate that we chose, which was granulate, because it was the snapping turtles nesting here, as opposed to the painted turtles, which we're not exactly sure where the painted turtles are nesting. But it was snapping turtles that were nesting on the roadsides. And there was about 100 a year. So we counted the number of snapping turtles that came up to these nesting mounds. We had 10 along Princess Street, and we found 63 of proposed 100 nesting, and the rest had nested along the exclusion fence. In year 2, we had close to 100 nesting on the mounds. But we did find, even though we protected them with the nest boxes, that the skunks were able to go underneath. So definitely something to pay attention to when you're protecting. And you do have to protect your nest mounds. We had skunks and raccoons. Skunks the first year, more so. Then raccoons caught on in the second year, and now they just have taken over our nesting mounds. So definite maintenance with nesting mounds. Luckily here, we didn't need, we don't need to put the hatchlings into incubation because they are able to escape from the nest boxes right into the water. So we showed in that year monitoring 96% of the hatchlings hatch from underneath the nest boxes that weren't predated close to water, and they all made it to the water as far as we know, and there was 0% road mortality. Okay, hurrying up here. I got 3 minutes for the last project in Long Point area. We were lucky to have funding with Environment Canada in the priority place. And we were able to take some time to identify corridors. So we had a movement corridor from Norfolk County Road 60, right, Long Point region along the Big Creek corridor, where we found a lot of road-killed fox snakes. That circle that just popped up to the right is where we had a turtle corridor migration that I talked about from Turkey Point Marsh up to Front Road, where they nested, and across to agricultural lands. So we wanted to keep them on the south side of the road to nest, effectively not having to cross the road. So we didn't need any structures for connectivity. And we were lucky that that spot where they were crossing from the marsh across Front Road was on private property, Eco Adventures. So that's really important, is to find a spot where you know you will have access to put your mitigation in. So what we did 250 meters of Animex exclusion fencing again. We weren't worried about snow destroying that fence because we were able to go far back enough from the road And we were worried more about aesthetics because people were going to see it. So we made the posts exactly the same distance apart, and we took a really lot of care in the construction of the fence, and it's standing very well today. We put the nest mounds on the inside of the fence to capture the turtles as they came up from the wetland. So this was a little bit different. It wasn't in a wetland. It was in a more of a prairie type grass meadow environment. Very easy to dredge with the machines because of the substrate, and but also definitely a lot of maintenance, keep the vegetation away. Year two, we had a Blandings turtle use it. You can see that vegetation is encroaching. Definitely every spring you have to get your volunteers. We have volunteers all ready to go every spring, gung ho, no matter what, every year to as part of a program with the Biosphere, who we partnered with, Long Point Biosphere. So we get the nest boxes out. We have the turtles. We watch for these turtles to nest because the nest, we don't want the nest box, because I'll tell you why, because the water is too far away for the hatchlings to get there. So we started a hatchery, and we bring the at-risk nests from predation and not being able to get back to water, and from road mortality, we bring them to the hatchery. And we also found that when the turtles do get on the road, we're able to lift them up and carry them off the road. So where do you put them? Well, luckily, we have our designated safe sites at every hotspot crossing that we patrol, and that happens to be behind the fence there. And then we have a chain link fence further down the road where we put them. And so we have volunteers doing the patrols for that as well. We had a hatchling release study to verify what I just said, whether or not those hatchlings can get back to the water. This was a partnership with the University of Waterloo, and they found, I think, of 20 tagged snapping turtle hatchlings. 2 made it close to the water down below, but after 28 days of monitoring, because that's all the tags will allow for, none made it back to safe hibernation water sites for that year. Okay, so I talked about, and all I want to say is that there is guidelines for this stuff coming out, and that we need a new model for an Ontario Road Ecology group, which is sorely needed. And we do have a lot of data being collected with iNaturalist projects. And I'll leave it at that.
Wonderful. Thank you for your presentation. Michelle, looks like you have a question. Go ahead.
I do. Thank you so much, Kari. That was really, really informative. I do have a question more about your equipment. So unofficial plug, I'm with Totally Restored, and we have a snake habitat creation course where we are building Hibernacula. And I want to start a monitoring program for it. And I'm wondering which cameras or stop motion equipment you would use for that and effectiveness.
Right. Well, that's a good question, because we know that the turtles and the snakes are cold-blooded, and so that's a tough one. And we can talk more about this offline, sure.
Yeah, for sure.
So the Reconics are the best, but they just do time lapse that is effective. And the newer models, I think they do up to 15 seconds or maybe even 10 seconds. So that's what I've been using just because I have them. But there's halt cameras which do triggers that's active trigger, so it breaks a beam. But that they don't necessarily all work in water. So that's, yeah. And so there's been some talks at the CHS actually that I have to follow up. There's a fellow in Kingston area who had underwater cameras. So I needed to follow up on that. So there's a lot of definitely hurdles to this kind of camera monitoring.
Yeah.
But there is some ways around it to a certain extent.
Sweet. Thank you. And yes, I will contact you to
more. That would be great.
All right. Thanks.
Yeah, maybe you can follow up with some of the people I haven't had time to follow up with.
Yeah, I'll let you know.
Any more questions?
We got a quiet crowd today.
Yeah.
I have a question. Hi. Hello. Hi,
Hi.
Kari. Maybe you can't answer this, but I was wondering, do you know what it cost? Like, I know it would probably be site specific, but for a municipality to install an eco passage under a road, I mean, yeah, like it would be site specific. But what are the general costs associated with installation? Do you ever work on budgets and stuff
Yeah,
like that?
I'm getting more into that, understanding the cost because there can be gouging, especially because of the uncertainty, not necessarily intentional gouging, but uncertainty of not knowing what's going on. So I'm trying to be there to say it doesn't have to be so not understood, right?
Right.
And learn how to do it. So for example, at Trent University, they just put in an ACO open top tunnel. And so I made sure I was on site. It was my first time, so I learned a lot too. But um, the pieces of they're 1 meter pieces, they're about $1,000 each. So you're looking at 12 to 15,000 for a 2-lane road. And then installation should be 1-to-1. So you're looking at that installation, that material cost 15,000, no more than 30 to put it in. And if there's road closures, maybe there's a little bit more extra money for that if
Right.
there's additional hurdles. But I like to look at the 1-to-1 materials to installation costs. So if you have $90,000 of fencing, it should be 90,000. It's a start. So if you get somebody who says they're going to install it for 10 times the price of the cost of the materials, then that's a red flag.
Right.
Well, it is now time to move on to
Okay.
Mitch, I believe. So, want to get yourself shared up there?
Yeah. Yeah. 1 second. Um, oh, whoops. Sorry. So, working on the ins and outs of Zoom. Don't use it very often. Okay. You probably see my screen there. And everyone can hear me? Okay. Um, that's my. Okay, so hi, thank you. Thank you for having me. My name's Mitch Ellah. I'm an ecologist with Stantec Consulting. I'm based out of London, Ontario. Um, Today my presentation is titled Documenting a Potential Blue Racer Hibernaculum Using Trail Camera Monitoring. So in 2024, a little background information. In 2024, I had the opportunity to go to Pelee Island and do ecological site investigations on a property on Pelee Island. And so one of the surveys was, so I do a lot of wildlife surveys, and one of the surveys was a reptile emergence survey on this property. So we thought there could be blue racer on the property, and through background reviews, maybe some other species at risk reptiles as well, specifically Blanding's turtle, and fox snakes. So anyways, we went there in April of 2024, and I had some very good luck. So one of the things I was hoping to do was to find a snake hibernacula or potential hibernacula, and I had some really good luck. And I wanted to, it was super exciting results, and I thought that I would share them with everyone here. So there, yeah, I mean the results They were very exciting, and they provide insight into blue racer emergence and courtship behavioral ecology. Just, next slide. So some notes on blue racer. In Canada, blue racer are only found on Pelee Island. Population estimates around 250 individuals. They prefer dry, open to semi-open and edge habitat. So savannas, meadows, old fields, alvars, hedgerows, thickets, shorelines, open forest. On Pelee Island, blue racer hibernates in cracks and crevices in the island's limestone bedrock, but mammal burrows and tree root systems are also utilized. On Pelee Island, blue racer are known to emerge from hibernacula in late April. Adult blue racer often hibernates communally with other blue racers and other species of snake, and they require humid conditions in hibernacula via groundwater. Courtship and mating throughout the month of May after snakes have dispersed. So the information here it is going to be corroborated with the information that I documented with that monitoring. Whoops. Sorry about that. So Pelee Island is in Lake Erie, just as a reminder for everyone. I'm sure everyone knows, but here it is here. You can see my cursor. You see my cursor? Yeah, okay. So Pelee Island here, we have Point Pelee National Park, Pelee Island. Blue racer are found in the eastern extent of the island where habitat remains and where there's connectivity between suitable habitat. The property that I visited, I'm not allowed to share the exact property, but it was a mix of active and old agricultural fields, hedgerows, thickets, swales, forest patches, and water courses / drains. So it had a lot of the preferred habitat types for blue racer. There was an old human created pond on the property, and there was also a type of created alvar because of topsoil stripping, like previous topsoil stripping. There was a lot of edge habitat, so very good for blue racer. And then the surrounding lands were also naturalized with wetlands and thicket. So the survey and the photos I'm about to show you were from April 26, 2024. It was a warm spring day. It was 13 degrees Celsius, 10% cloud cover, and it was kind of windy with a Beaufort scale of 3. But it was after a 2-week period of cold, wet weather, and it was a really nice warm spring day. And it had been, like I said, rainy and cold. So it was a perfect day for reptile emergence and for finding reptiles coming out of their hibernacula or out of overwintering habitat. So I was walking around, like I mentioned, there's that old pond, right? So I'm walking around this pond and doing visual encounter surveys and turtle basking surveys. And I was also sampling water in this pond for eDNA for smallmouth salamander, which is a endangered species and only found on Pelee Island as well. So I was walking around this pond and I came across, well, as I was standing there, my hands were full of equipment, and I looked down. There's this large snake at my feet, and I just watched the snake, and I got the ID of a blue racer, and it went down. Didn't travel very far. It was clearly basking in this herbaceous riparian zone, and it went down this little hole here. So you can see the hole. When I went there, I went prepared with a trail camera, just in case I did find something suitable for hibernacula. And so is it like really nondescript hole? I'm not sure what created it. Maybe it was like a old mammal burrow. I don't know, or maybe it was a fence post hole. Not sure. It almost looks like there's a cone here, so potentially there was an old, mammal burrow. So I set up my trail camera, and it was about 60 centimeters away, and I left it there for a few months. And the photos I got were really, really awesome. So I had a blue racer visit the burrow. So the first day that I saw a blue racer, that was April 26th. Now the camera didn't see that blue racer coming out of the burrow. So potentially it left like a different burrow. There might be another one like an interconnected, like a separate entry or something. But then a blue racer shows up on April 28th. So that's 2 days later in the evening, 6:30, and it just looks in the hole, and then it leaves. So I have another blue racer show up on May 1st, a couple of days later. I think this might be a different snake. just based on the coloration of like the cream on the nose, it looks a little different. So then this second snake shows up and does the same thing. So then on May 5th, 3 blue racer enter the burrow, and that's in the evening. So that's at 8 o'clock in the evening. And then the next morning, they come out at 10 a.m. on May 6th, and they leave the burrow and they begin courtship mating right in front of the camera for 5.5 hours. So they're like, I mean, look at all these photos. They're just like, it was amazing. You know, when I got this data, I was really, really excited. Um, so they're, yeah, doing their courtship and mating. And just gonna slowly go through all these photos, let you look at them all. You know, posing for the camera. There were some photos early on, like when those snakes first showed up at the burrow, when they were checking to see, you know, if there are any other of their friends there, they were also like checking out the camera, like slithering up and over the camera. Like I don't know, they could tell that something was there that was different than normal, but it didn't obviously change their behavior at all. Look at that, so cute. Um, oh, okay, I only have. I should go quicker. So, anyways, after the courtship, the blue racer were observed entering the burrow again on May 6th at 2 different times. So that's that same day at 5 and 6 p.m. Or almost 7. And then so they stay there overnight together. And then the next morning they leave at 8:50, returning at 11:20, and then they disperse and they're not photographed again. So, you know, a lot of the information on Blue Racer are that they'll congregate soon after, like I said, soon after they emerge to do their courtship and mating. And so they spent overnight in the burrow. You know, there's a lot of reason to think that it is a hibernaculum and not just, you know, another a hole, you know, like whatever, like a hole that's less important. So, anyways, the key takeaways from the study or from the monitoring is that trail cameras can be an effective way to monitor potential hibernaculum. I'm sure a lot of people know that. When you know where the hibernaculum is, it works really well, right? You know, it takes photos of the snakes entering and using it. Early spring surveys at emergence are an optimal time of year to survey for snakes and hibernaculum. Like that was a perfect timing. You know, I had great weather and the vegetation is still low, so you can see the snakes when they're out. And then they're also basking. They're a little slower than normal, and they're just getting, you know, adjusted to their active season again. So on that same day, I also saw a Blanding's turtle basking, snapping turtles basking, painted turtles basking, and then it was the most amazing day, and then follow up by this data here. So like if you're gonna go out and if you're thinking that you could have some reptile habitat on your property, have a trail camera with you so you can deploy it if you see something like what I had there. The burrow showed high potential as hibernaculum habitat, so there was communal use and repeated visits supporting the high fidelity. Blue racer are known to have high fidelity to their hibernacula. It was in proximity to the ponds, so that provides groundwater and or humidity. And then there was that basking snake during emergence period. And then there's the proven suitability for overnight use by multiple snakes, courtship and mating after dispersal. So, you know, all signs pointed to the fact that it was a hibernaculum. I would have gone back and I would have studied it again in the fall just to confirm to get entry, but unfortunately the project was canceled and I never got a chance to go back, so that was pretty unfortunate. But I would have, you know, redeployed in the fall. And that's the presentation. Thanks.
Awesome. That's such a cool finding to be able to capture those photos.
Mm-hmm.
Amazing.
Yeah, no, it was really exciting.
Looks like we have a question in the chat. How did you
Yeah.
sort through the camera data, and did you use a program or doing it by hand? And that's by Ali.
Yeah, that's a good question. So I did this just visually searching through every photo. It is pretty time consuming. We've, the trail cameras, they trigger really easily, and they take, you can set them up for, whatever settings you want, 1 photo or 3 photos or up to 10 photos per trigger. We also use the Reconyx. You can see there the Reconyx. The Reconyx trail camera for the study. But there are AI programs now, software programs that will sort through your trail camera photos because sometimes we'll come back with trail cameras and there'll be 10,000 photos and there won't be a single snake on them. They'll just be a single leaf moving in the wind over the course of three months. So if you can get access to a software, I'm not sure what's available right now. I know that like at Stantec we do have software that we can use. I just haven't used it yet.
Okay, cool. There's a few more questions in the chat if you have a chance to maybe answer them there, but otherwise we will move on to the next presentation, which is Dorian.
Thank you.
All right, thanks, Christie. Oh, I think Mitch might have to stop sharing first. Perfect. All right, does that look good? Okay. So thanks, everyone. Good afternoon. Thanks for having me here today. My name's Dorian. I'm a ecological consultant with Natural Resource Solutions, and also recently a doctoral graduate with the University of Waterloo. And I'll be presenting some of those results from my doctoral research here today, looking at ecological thresholds for frogs and toads in Ontario. So in general, what we see across many landscapes in Canada is a continued expansion and intensification of human infrastructure, particularly in areas with habitat that's already been impacted historically by fragmentation. The results are an increase in roll mortalities, continued reductions of habitat size, isolation of habitat patches, reductions in landscape permeability, among many other negative impacts. Now, the current approach to maintaining habitat connectivity for wildlife includes recommendations that are fairly vague, sometimes open-ended, and vulnerable to malicious misinterpretation. But this is somewhat understandable because figuring out how much habitat a species needs is pretty difficult given the complexity of the interactions involved. Most of what's been quantified to date is the amount of a particular habitat within a radius of core habitat, which is useful only to a point because it doesn't tell us much about what should be happening in between those habitats. My work focused on anurans. In particular, they're a potentially useful indicator species, fairly easy to monitor during breeding, and are pretty mobile. We already know that anurans generally need more than a 30-meter vegetative buffer around their breeding wetlands to persist and thrive. They're a group of species that rely on dispersal and migration movement dynamics to fulfill their life cycle, and they instinctively use a range of habitats across the landscape. And landscape connectivity management generally relies on the usage of large and wide habitat linkages, which are a logical solution for connectivity between habitat patches, but only if the traveling individuals have the capacity to follow that ideal pathway or even have a high enough likelihood to discover it at all. And there's a question of what happens to the individuals that travel in the other directions who don't have the sensory capability to detect a suitable destination habitat further away. And so in response, a lot of connectivity modeling uses resistance-based approaches that typically assign values to land covers that reflect the resistance of that land cover to anuran movement. And these are widely used to identify corridors and connections. Widely used approaches like CircuitScape provide outputs wherein a range of possible movement corridors are identified, but a couple of underlying assumptions of these approaches are incompatible with our current understanding of anurans and many other wildlife movement dynamics. I'm going to focus on two major shortcomings here. The first is that these models generally assume that the individuals will select the least resistive land cover each step of the way, which frequently results in pretty sinuous pathways and linkages, as you can see here in this example output. This is generally not true for directionally moving dispersing anurans, and it's often why we see them in such large numbers crossing what we would consider inhospitable land covers like roads and parking lots and other urban areas. Secondly, in a lot of resistance modeling approaches, roads are assigned higher resistance values to reflect the potential for road mortality. But road mortality as a mechanism should be modeled as an exponential reduction in survival, not as an additive resistance. The outputs that you see here, for example, are very different depending on the mathematical approach taken. And assigning larger resistance values to roads cannot really replicate the reality of exponential reductions in survival after crossing multiple roads. So in this research, I designed some alternative metrics for anuran habitat connectivity that specifically addressed their movement dynamics, behaviors, and limitations. It's likely that a lot of other terrestrial wildlife exhibit similar movement limitations, like turtles and snakes, that render current habitat linkages less effective than they could be. I then looked to identify the actual thresholds in these metrics that can be used to inform landscape connectivity design. So the presence of 6 commonly occurring anuran species in Ontario was used as the response for this analysis, and the presence was determined using acoustic data from the amphibian marsh monitoring database organized by Birds Canada. After a lot of site filtering, 290 sites were selected for use, the locations of which are on that map there. So they spanned a pretty large area across southwestern Ontario. I designed 3 connectivity metrics. Now, the first aimed to capture juvenile dispersal behavior by dividing the landscape into 12 overlapping wedges, which simulates the anuran's directional movement while allowing for some lateral meandering. Resistance models were run for each wedge individually, and the final metric output was the number of wedges out of those 12 that contained accessible marsh wetland habitat as a destination. Now, the second metric used forest as a destination habitat and captured movement from breeding to overwinter habitat, since some species overwinter in those forested areas. Resistance models with no lateral restrictions were executed, and the output was the area of accessible forest standardized by remaining energy. And the third metric for connectivity specifically isolated reductions in survival due to road crossings. Each road was assigned a value for the probability of successfully crossing without being killed by vehicles, and a minimum of 5% survival was used as the cutoff for being considered connected. And then the final output was the area of accessible marsh wetland habitat. And what you see here is just an example of one of the outputs. And in addition to those 3 connectivity metrics, I also executed some more traditional ones, which just looked at the amount of land cover within 3 radiuses of the core breeding habitats. The first was the area of forest and wetland, the second area of urban land cover, and the third was just all vegetated land cover, which included agriculture. And just quickly, I performed some regression analyses using generalized additive models, but I won't go too much into that. You'll notice, just based on the deviance explained values in brackets for each species, that the peeper and the tree frog both had by far the highest variance in presence explained by these metrics. And regardless of those regression results, I looked for threshold responses in all of the metrics. To do this, the data was organized into 20 bins of equal number of points, and then piecewise regression was executed in R. Now, taking a look at some of the results, I'll focus on the peeper and the tree frog again because they had the strongest responses to these metrics, both on the regression and the breakpoint side of things. Here we have a decent threshold response for the peeper on the left and the tree frog on the right for the juvenile dispersal metric at 5,000 meters. As you can see, the red statistically identified breakpoints, they differ from the visually identified breakpoints in green. So it's important to visually examine the data after using a statistical approach to identify breakpoints. The overwintering habitat at 3,000 showed some clear threshold responses for both species, with clear points at which reductions in accessible overwintering habitat led to steep drops in species presence. And again, note that the statistically identified breakpoint for the peeper didn't really hold up to visual scrutiny again. And it's a similar story with the road crossing survival metric at 5,000. There's once again clear points at which reductions in accessible marsh habitat led to steep drop-offs in the likelihood of peeper and tree frog presence. Briefly touching on one of the land cover composition metrics, this one is for total forest and wetland cover within 3,000 meters. Once again, the threshold responses are pretty clear and strong for the two hyelid species at the bottom, the peeper and the tree frog. While for the other four species, the relationships varied in shape and magnitude. I'll discuss possible reasons for that in the following slides. So as we've seen, local maximums and minimums did play a role sometimes in the breakpoints. The outliers weren't necessarily common, but occurred enough times that it's always important to visually inspect the data to confirm all relationships, because the stats alone could be quite misleading. What do these look like when they're visualized? So here we have some significant thresholds for the peeper. First, we have the amount of accessible marsh habitat within 5,000 meters after factoring in road crossing survival. Note that this area of marsh can be distributed throughout that 5,000 meter area as long as all of it remains accessible, aka within reach, and a maximum 95% mortality due to crossing roads. Second one here is the area of accessible overwintering habitat within 3,000 meters. And the third one is the accessible marsh habitat within 1,000 meters after factoring in road crossing survival. And finally, here we have the number of dispersal directions which led to accessible marsh habitat. The key takeaway here is that these thresholds don't result in a huge amount of destination habitat needed, but they do provide additional guidance about the distribution and spatial accessibility of those features with considerations for anuran movements, something that's been largely missing from other habitat threshold and connectivity analyses. Here we have the land cover composition thresholds for the peeper. These ones result in larger required habitat areas, but because they're so vague, there's no additional indication of where to place or how to distribute those land covers. But I will bring your attention to the vegetated cover result, so that last one in beige there, which includes agricultural land, and look at the difference in proportion of area compared to the forest and wetland cover. And given the strong threshold responses with the vegetated cover metric, there's a pretty good indication that agricultural land plays a big role in either providing habitat or ensuring a more permeable landscape for anurans. And they should be given more consideration from an ecological perspective when designing landscape linkages. Some key takeaways here. First, as mentioned already, the presence of tree frog and peeper were notably more impacted by the connectivity and land cover composition metrics than the other four species. This is important because peepers may have already been identified as potentially strong indicators of ecosystem health and biodiversity. They're probably the easiest species to identify acoustically, and designing a landscape around their needs could encompass the needs of a wider range of other species, including reptiles, amphibians, mammals, and birds. But some of the metrics may be less suitable for certain species. Take the wood frog, for example. They consistently prefer to use ephemeral ponds for breeding. But identifying and delineating ephemeral ponds in a provincial dataset with 15-meter resolution isn't usually possible or pragmatic. Similarly, the toad is a generalist who can breed and forage and shelter in a wide variety of features, so the way that these metrics were designed is likely not suitable for determining the toad's habitat requirements. But fortunately, the toad isn't much of an ecosystem indicator. And in summary, there's many practical opportunities for future connectivity modeling specific to anurans and other species groups with navigational limitations like salamanders, snakes, and turtles. Identifying these kinds of thresholds can help guide conservation planning to actually create robust, effective, and connected wildlife corridor networks. Thank you.
Great, super interesting. I'm a road ecologist too, so I'm like, always interesting. Great. What do we have for questions? Anything that people would like to ask?
I could ask a question. Hi. Did you collect road mortality data for all your metrics, like to see where or how many frogs of all various species got killed and how far they could move? Or I was also thinking like what type of would it matter what type of roads there are, like roads with curbs and versus roads without curbs?
Sure. Yeah. So the first part, this wasn't necessarily an exercise in validating the model results. So you could certainly model the road crossing survival components and then identify intersections with road segments and look whether the road mortality of frogs, toads, and other reptiles is sort of corroborated by the model. But that
Right.
would be sort of a different exercise in validation.
Mm.
And sometimes we see that areas that might be identified as hotspots are no longer so because of the historical road mortality that's been going on for a long time, depleting the population numbers in that area. So it's a bit
Right.
of a tricky exercise in itself.
Mm.
And I can't remember the second part of your question.
I think the second part was just considering if the type of road that are within your study area, if that, highways versus paved roads, dirt roads, roads with curbs or not.
Yeah. So yeah, the different classification of roads was factored in because the mortality rates will vary dramatically. And what was also factored in was the where the roads were located, so whether they're in urban areas or rural areas, because the classifications and the traffic intensity can vary in those two areas, despite having the same classifications. And then the last thing that was factored in was sorry, so there's urban, rural, there was the type classification and the time of day. So traffic, a real world traffic intensity data was used to determine those survival rates. And since we know that amphibians generally travel at night and not during the middle of the day, the average nighttime traffic intensity was used.
Right.
So if you were doing, for instance, a modeling for turtles, which move generally during the daytime, those values might need to be shifted a bit.
Okay, great.
Thank
Thank
you.
you so much. We will then move on to our one more presentation before our break, which I believe will be by Anne. So if you want to get started. I think you're muted.
That's not good. Okay, can you hear me now? Okay, sorry about that. Hello, I'm Ann Yagi. I'm the systems ecologist and president at 8 Trees Incorporated. In my former life, I was the provincial biologist for the Niagara area. Today, I'm going to talk about a long-term research and monitoring project that began about 30 years ago when a portion of the study site was purchased by the Nature Conservancy of Canada for bog restoration and recovery of rare species populations. And the project continues today, just to let you know. So it's all about a small venomous rattlesnake called the Massasauga. It's found in eastern North America in the Great Lakes lowland region. The preferred habitat are wetlands, forests, meadows, grasslands, and rock barrens, often near water and shorelines.
And I don't mean to interrupt. Do you want to share your screen?
Did I not share it?
No, I don't see anything, at least on my end.
Well, I went through the motions to share it. Share.
I apologize. That was a fabulous start. Just want to make sure you can
Okay.
see your slides.
Share. Can you see it now?
Yes.
Okay, sorry. Now I can't see mine. Okay. All right. So, yes, okay, I was talking about the Massasauga rattlesnake. And it's a small venomous snake, and it exhibits site fidelity to hibernation features, which is a big part of our understanding of our project. Subterranean features are adjacent to wetland features with surface holes, burrows, and cracks in ground. The threats for the species are habitat loss, poor habitat quality in the case of our study, persecution, and road mortality. So this is a map of the locations of the extant and extirpated counties in the United States and Canada. The orange dot means extant and the white dot in each county means extirpated. And the red arrow is where the Wainfleet Bog study site is located, which is just on the north shore of Lake Erie in Port Colborne. The status range is globally least concern in Canada threatened, and the United States mostly endangered, except for Michigan, where it's special concern. So overwintering is a really critical life stage. Snakes living in temperate climates spend more than 50% of their time underground, and neonatal snakes are naive, okay, and therefore vulnerable to overwintering mortality when the habitat quality is really bad in their study site. So altered landscapes increase mortality risk and raising concerns about ecological traps and increased extinction risk. This is a picture of our study site, both in a wildfire state in the top and in the bottom is a flooded state within just a year or two. So part of my master's research was looking at resting metabolism and post-dive recovery in garter snakes, red-bellied snakes, and the eastern Massasauga. And cutaneous respiration is the passive diffusion of oxygen through the skin membrane. And all species are able to do that under ideal conditions of highly dissolved oxygen in the water during a forced dive, okay? However, all species also incurred an oxygen debt, which means they didn't get enough oxygen during the dive, and that also means they need access to air oxygen. And this is especially relevant limitation for snakes overwintering in low oxygen environments such as bogs. So our study location is the Wainfleet Bog. It is located in the Niagara region of Ontario. It's a significant wetland, nationally significant, mostly because of the Massasauga population, which is the last remaining large population in the Carolinian zone. And the problem with this site, let me see if I can get that right, okay, is that red outlined area was peat mined from the 1950s to the 1990s, then left as is to naturalize. And that is, and so therefore it experienced a lot of stochastic events of flood and fire, like we showed you earlier. And it's also currently still being drained, and that drainage effect by the municipality affects all the hibernation areas throughout the site. So we've also completed long-term monitoring of the population. And the radiotelemetry work really showed that the Massasauga showed site fidelity to the peat mined area. So they got in right away after post peat mining and established site fidelity to some hibernation areas and some holes they found. And we also knew that snakes moved from the areas surrounding that, which is the not mined area, and they moved into the peat mined areas for gestation and hibernation, and they were able to move back to the hibernation areas in the not mined area, but some spent their entire life cycle in the mined area. Okay, so that really confirmed concerns about ecological traps and increased extinction risk. We began long-term monitoring of the hibernation areas and the ecosystem back about 30 years ago, and we monitor the ecosystem using data loggers, hourly set, and the hibernation areas are monitored manually by measuring life zone factors of groundwater dissolved oxygen, groundwater levels, temperature, snow depth, that sort of thing. So as a life zone is a subterranean aerobic space where snakes overwinter that's below the frost line and above the water table. And it has surface holes to vent the biogases produced over winter in bogs, and of course the holes allow snakes access. So the graph above, the top graph shows the not mined area, 11 winters of life zone monitoring. The gray area patches are the winters. The blue line is the frost depth. The black line is the water levels. And the area below is the mined area, which shows at the red arrow and beyond where the life zone disappeared for a series of 5 years. So we studied hibernation habitat function in the peat mine fields and the not mined areas, and there were differences in the amount of life zone established over winter, and that difference was related to the difference in the catchability of snakes the following year was a high, strong correlation. So we've confirmed a positive correlation between habitat quality, hibernation habitat quality, and snake survival. So we also documented a population crash during the first flood events post peat mining. So the population crash was validated by our index, which each column shows an annual true number of snakes that we encountered. They are the number of marked snakes, number of recaptured snakes, and snakes that we didn't find that year, but we found in the future. And based on their age, we backcast them into the population. And we found that there was a strong correlation in the decline of life zone and this population curve. And most of the curve after 2010 is related to snakes that survived in the refuge area around the flood event. So what is forced hibernation? It's a method that I developed to enhance neonatal snake survival their first winter, okay, to get them to survive in areas and establish site fidelity to good quality habitat, which is the areas that were not mined. So the not mined habitat areas is the best. So our objectives were to, does forced hibernation improve overwinter survival in neonatal Massasaugas, and can it be used as a conservation tool? And can it be used to improve population viability in the longer term? Now, I went in the lab and I tested and looked at hundreds of hours of tape, videotapes of pictures of snakes moving up and down in these burrows that I designed for them in a vertical space. And we looked at them over complete winters in the lab at cold temperatures to validate the design of the burrow. So we used small groups of wild captured neonatal and juvenile garter snakes at first to test for the first 2 winters their survival, to test the method in the field. And then on winter 3, we used a small group of Massasauga neonates and we tested them alongside the garters. And in winter 4 and 5, we did the full application of the method on a larger sample of neonates of both species. And we found neonatal snakes, they're born in the lab from captive raised females, and we feed them weekly, and then we test their movement abilities in the burrows before we put them out in the field. And they're out in the field from mid-October to mid-May, about 200 days, and in the life zone areas only. Okay, and then survival's checked in the spring. We don't manipulate anything over winter. We don't disturb the sites, and the artificial burrows are removed. They're not kept there. This is our results for the first 3 winters. Had excellent results, over 80 to 100% survival of both species. And then the next 2 winters, we had lower survival. So that brought up some concerns. So we did some model testing, the Kiki model testing of biological factors, environmental factors, and life zone factors. And we found out that if garter snakes were over 5 grams or bigger, they had more than 80% chance to survive. And with Massasaugas, it was about body condition. We didn't want them growing thin, need them to get fat. So we went to a part 2 method, which is forced hibernation and head starting. And we basically fed them ad libitum to get them fattened up. And our survival rate was over the 80%, 80 to 100% survival of both species. So as I said before, I controlled where I put them. So they only went in areas that maintained a life zone. This is a similar map showing 9 winters now of data. And these 9 winters showed these gray areas where the life zone was maintained. The survivorship is on the top of the chart, and the gray areas show the life zone from that. So then we put it all together and monitored, established whether or not in our index, whether or not we had a recovery. And we can say today that we have a managed recovery based on our population marker capture work. And, which is good news, we basically said that forced hibernation is probably a good tool to use, and that it can be a good conservation method to increase survival. And then we looked at it in terms of population viability and plugged it into the population growth rates during different scenarios before we did forced hibernation. So about midway through our study sample and then after, and we're able to show that yes, if you continue, you will have an improved chance of long-term recovery for the population. And how am I close to the end? Okay, good. So these are all my thank yous. There's lots of them. And we're still assessing the limiting factors affecting habitat quality, which right now is rapid ecological succession of the not mined areas. So the good quality habitats are succeeding really fast into trees and shrub habitat, which is escalated by drainage. And we're also testing a softer release method called assisted hibernation, where we just fatten them up and get them back out in the field and let them pick their own site, but we put them out in life zone areas only. And that's it.
Wonderful. Thank you so much. Is
there any questions?
Raquel, you have your hand raised?
Yeah, thank you so much. I've read your paper before previously on this, and it was very helpful. I do have a question, and I'm sorry if this was covered. Since they have such like a high site fidelity for that overwintering habitat, once they're past that neonate stage, how do they, like, are they looking for what they were previously overwintering in, or how, is there any?
They're not looking for a specific hole, they're looking for a specific area. So it's site fidelity to that area that supports the success of the project. It really does. There's no, I don't leave an artificial burrow out there. There's so many holes in this area. There's so many opportunities. And then the population mark recapture work shows that they are still there and growing and contributing.
Okay, so they're not necessarily like going back to the same hibernaculum every overwintering. No. It's just they're looking for that space in those right conditions.
That's right. Because don't forget, neonates grow, right? They get bigger. They might need a bigger space.
Right. Okay. Yeah, that makes sense. Okay, sweet. Thank you.
Welcome. Oh,
there is a question there. Any potential contamination associated with peat mining?
Contamination, we've not measured contamination issues there. The peat mined area, though, from a physical standpoint, is just not suitable for to sustain their whole life cycle in that area yet.
Okay, great. Thank you to all the presenters who have gone so far. We will now be taking a break, so we will return at 12:10 Central Time, which should be 1:10 Eastern, and what is that, 10:10 Pacific? But yeah, okay. So we'll see you back in a bit. Okay, it is 1:10. So, or well, 1:10 my time. So now that we've returned from our break, I believe our first speaker is Robyn and Raphaëlle. So if you guys want to get started.
Yes, thank you. Just share my screen here.
I think you might be muted, Robyn.
Oh, so sorry about that. Can you hear me now? Okay. So my name is Robyn Hirsch. I'm a student from Dalhousie University, along with my co-presenter, Raphaëlle Dupré, and we're really excited to talk to you about our joint research on a new method of freshwater turtle nest protection, which is being done under the supervision of Dr. Amy Mui, who I believe is also here today. So I'll just jump right into it, make up for that lost time. As we've mentioned, turtle populations have been in decline across Canada, with nest predation by species like raccoons and foxes being a major threat to reproductive efforts. And these species primarily use scent to locate nests. So currently, nest cages are the main protective tactic used in the field, but are quite time and labor intensive to deploy. So our project is proposing a new conservation tactic known as olfactory misinformation, which essentially uses scent to manipulate predator foraging decisions by teaching them not to associate certain smells with food rewards. This is an increasingly popular conservation tactic and has been successful with various shorebird species, and this literature specifically recommends applying it to protect nesting turtles. Our idea is to basically create an artificial scent solution mimicking turtle smells to camouflage nesting sites with, making it difficult for predators to pinpoint the location of real nests. And with repeated unrewarded encounters with this fake turtle smell, they learn to ignore it and view it as an unreliable cue, essentially. Now, to create this artificial turtle smell, we need to know what chemicals composed those scent cues, with my research specifically asking what volatile organic compounds are emitted by nesting females and hatchlings of freshwater turtle species native to Nova Scotia, which is where the study took place. My methods involved swabbing nesting females and hatchlings of native Nova Scotian species, including snapping, blandings, and painted turtles. Amy and I sampled turtles from around the HRM, as well as some in rehabilitation at Hope for Wildlife, where we had some help with Parks Canada and MTRI collecting blanding samples down in Kejimkujik. And this occurred during the 2024 nesting season. So for adults, we would take both external and cloacal samples, while for the hatchlings, we would focus just on their umbilicus belly area. With help from Dal's Marine Lipids Lab, the samples were analyzed using gas chromatography mass spectrometry, which can identify all of the volatiles in a sample and their relative concentrations. And my goal here was to figure out which appeared most consistently across samples and in the highest concentrations. So across 49 different samples, there were 160 unique volatiles, really showing you how complex these smells could be. But despite this, I was still able to narrow it down to 2 chemicals that primarily characterized nest scents for all species, being linalool oxide and 2-ethylhexanol. You can see here that they were consistently observed across both adult samples, as well as present in egg and hatchling samples as well. Now, this is a pretty lucky finding because it allows us to create a single generalized scent solution used to protect all populations during both the spring and fall predation seasons. So the next steps of the project are to actually create and fine-tune the scent solution to ensure it elicits predator responses before we move into all-out field trials. But this is where Raphaëlle's work took over, so I'm going to let her take the mic from here.
Yeah, so building on Robyn's scent characterization work, I, in collaboration with the Dalhousie Marine Lipids Lab, created an artificial turtle nest scent based on those 2 compounds that were found in the highest concentrations, which, as Robyn said, were linalool oxide and 2-ethylhexanol. The next step in the project was to determine whether the scent was comparable to a natural turtle nest scent and to determine its potential uses for olfactory misinformation. So our 2 research questions that were associated with this section of the project were whether mammalian predators exhibited any investigative behaviors toward the artificially recreated nest scents, while the second research question examined the minimum concentration of artificial nest scent required to elicit those investigative behaviors in mammalian predators. I'll be explaining the specific goal of each piece of my project as I go along. And for a little bit more context, investigative behaviors in this context were defined as any interaction with the scent or surrounding substrate, which included sniffing, licking, digging, or other similar activities. Data was collected at Kejimkujik National Park, the Wildlife Ethology and Canine Olfaction Lab at Dalhousie University, and Hope for Wildlife, which is a wildlife rehabilitation center located in Nova Scotia. At Kejimkujik National Park, our goal was to determine which scent concentration, if any, caused investigation by the predators. So we sampled 3 sites in areas that were within known turtle territory but outside of the active nesting areas, and we set up trail cams at each site to capture any activity. Sampling was done from May to August of 2025, and holes were dug 6 inches deep in the soil, and then 1 of 4 varying concentrations of our artificial scent solution, which were 0.5, 10, 15, and 200 micrograms per milliliter, were laid down in each hole. 20 drops of each concentration were put into each hole, and then we shallowly recovered those in soil to prevent evaporation. With these methods, we won't be analyzing any data because there were no results on the trail cameras, which we believe was caused by a distillation error of the scent. And we did have the Marine Lipids Lab redistill our scent solutions for future trials in order to prevent the issue from reoccurring. At the Canine Olfaction Lab at DAL, our goal was to determine whether any of the concentrations were detectable at all. So to do this, we tested 2 dogs that had previous experience sniffing out wood turtle nests. We placed 6 funnels apart, and a vial containing either a scent or a blank of sterile water were placed under the funnels for the dogs to sniff. And we were just trying to see if the dogs could sniff out the correct artificial scent. 5 of the funnels received the blanks, and 1 received the scent that we were trying to test. Scent placement was random and selected using a die. To avoid cueing the dogs, the handler was kept blind and did not know which funnel contained the scent, and we also placed uncapped vials of the artificial scent in a hole filled with paper shreds, which you can see in the middle photo there, to see whether the dogs could find the hidden vials by scent, which would also tell us whether the dogs are able to detect the scent. We will be analyzing the sniff time for each funnel and running a t-test to see whether there's a significant difference between the sniff time for the blanks and the scent, and if there is, we'll know that the dogs can distinguish between these 2 scents. At Hope for Wildlife, we sampled juvenile raccoons born in July of 2025, and our goal was to determine whether our artificial scent is comparable to a natural turtle nest scent. Ideally, we would have tested adults who had prior experience depredating nests, but there were no wild adults at Hope for Wildlife when we did our tests, so we stuck with the juveniles. However, they might have some instinctual predatory behaviors when it comes to predating on turtle nests, so they still provided us with some very valuable data. So as you can see in the left-hand photos, we set up a cage inside of an empty raccoon enclosure to be able to film and clean a little bit more easily and to have a bit more of a controlled environment. We followed a habituation-dishabituation protocol, which basically just seeks to determine whether 2 scents are distinguishable from each other. And to do this, we placed 2 bowls of sand inside the enclosure, one with a control scent, which was just sterile water again, and one with our artificial scent, and in this study we used the 15 microgram per milliliter concentration of scent. The raccoons were exposed to the scent 4 times for 2 minutes each time, and there was 1 minute between each exposure where the raccoon was removed from the cage and everything was cleaned. On the 5th exposure, the artificial scent solution was replaced by a real turtle scent, and between exposures, the cages and bowls were cleaned to prevent scent contamination. Additionally, as you can see in the right-hand photo, we left out a trail camera with 3 bowls of artificial scent, natural turtle scent, and a control, which was sterile water yet again, to track any behaviors overnight when they're most active. Again, our results will be analyzed using a t-test, which will tell us whether the sniffing time between the first 4 exposures and the 5th exposure is significant, which is standard for a habituation-dishabituation test. If that is the case, then we know that the raccoon does consider the 5th exposure novel, meaning that the artificial scent does not accurately replicate the natural turtle nest scent and might not be a great candidate for olfactory misinformation uses. The trail camera footage will be analyzed by sniff time of each bowl to determine whether the artificial scent, natural turtle scent, or control are most investigated, which will help us learn whether our artificial scent is in fact similar to that natural turtle nest scent. So the next steps for this project are to analyze the results of my trials at the Canine Olfaction Lab and at Hope for Wildlife, and to provide recommendations for future use of the artificial scent in olfactory misinformation work done by future researchers. So studies will use the best scent formulation and concentration determined through my project in order to test the scent in more biologically relevant scenarios to continue investigating the potential use of olfactory misinformation as a freshwater turtle nest protection strategy. Thank you very much.
Super cool. That's super neat. I'm excited to see the next steps. Do we have any questions?
as a comment, but saying great work.
Thank you, Amy.
Oh, and we have some raised hands. I guess we'll start with Daphnée. Daphnée.
Yeah, hi. Great presentation. Really interesting because as you'll see later, maybe my project is also on turtle nest protection, and I was wondering, like, how easy is it to make the fake scent? Like, could other university labs make it, or would it need to be like processed and bought after?
That's a great question. We didn't create the scent ourselves. We had, like I said, the marine lipids lab at Dal distilling the scent for us. So I don't know the exact mechanism that they used in order to do that. But based on my understanding, all they really did was get the linalool oxide and the 2-ethylhexanol, and then first they distilled it in ethanol because that's what those compounds are soluble in, and then they further distilled that in water. So I think that it should be relatively replicable by other universities if they were looking to do something like that.
Awesome, thank you.
Sorry. So I had one question. It was about the controls for the dogs. Did you use something like with a very obvious scent for them to find that wasn't turtle related at all as a control, or did you just use blanks?
We just used blanks, so all we wanted to see for those trials were whether the dogs were able to pick up on that turtle scent and whether they distinguished that it was different to the sterile water, just to determine whether our concentration was high enough and detectable by those mammalian predators.
Okay, great. Thank you so much. We will move on to our next presenter, which is Katelyn. Leave.
Hello.
Right.
Are you able to see my presentation? Hello?
Yeah, we are good to go.
Okay. Way Nindeloise Katelyn Augustine. Hi, my name is Katelyn Augustine, and today I'll be discussing my project assessing the presence of McGeege in central Gespe Gawagi using two-eyed seeing and environmental DNA. Oh, wait, actually, before I begin, I'd also like to acknowledge that currently I'm residing on the unceded and unsurrendered territory of the Mi'kmaq people, and the university that I work for, that I study at, the University of New Brunswick, is on the unceded and unsurrendered territory of the Wolastoqey people. And so Mi'kmaq is Mi'kmaq for turtles, and Mi'kmaq are culturally significant to the Mi'kmaq people. Mi'kmaq as well are considered sacred to many Indigenous peoples' cultures and play an important role in ceremonies. As well, the turtle shell represents a calendar with the inner 13 shoots representing the 13 moons in a year and the outer 28 shoots representing the 28 days in a moon cycle. As well, turtles are considered the namesake for Turtle Island, also known as North America. So my project focuses on the 3 species of turtle in New Brunswick, those being wood turtle, eastern painted turtle, and common snapping turtles. And wood turtles are listed as threatened under the Species at Risk Act and inhabit the majority of the province except for certain watersheds in northern New Brunswick. Eastern painted turtles and common snapping turtles are both listed as species of special concern and inhabit the southern half of the province. But contrary to the previous slide, Mi'kmaq knowledge indicates that wood turtles had once and may still inhabit a watershed in northern New Brunswick. Along with this, on the same watershed, there have been individual sightings of both eastern painted turtles and common snapping turtles. But again, there are no established turtle populations or recorded turtle populations on this watershed. So what is two-eyed seeing, or Edawamuktuk in Mi'kmaq? Two-eyed seeing is the overarching framework of my project, and it's a guiding principle coined by Mi'kmaq elders Albert Marshall and Merdana Marshall. It means to weave together Indigenous knowledge systems with Western knowledge systems, looking through both eyes, i.e. knowledge systems, to gain a wider perspective and understanding of a subject. The use of Mi'kmaq knowledge in my project adds historical and cultural context to the research, and the overarching framework of two-eyed seeing helps to build trust and connection between Indigenous peoples and Western science. As well, the overarching framework of two-eyed seeing in my project is in accordance with the United Nations Declarations on the Rights of Indigenous Peoples and an acknowledgement of Indigenous peoples as rights holders. So in my project, Mi'kmaq knowledge will be used to aid in the choosing of sampling locations for environmental DNA and in understanding turtle behaviors and dynamics, as well as to help potentially assess past, current, and future threats to turtle populations in northern New Brunswick. So two-eyed seeing encapsulates the entirety of my project, including the interweaving of Mi'kmaq knowledge through interviews and analysis of those interviews, as well as the collection of environmental DNA samples, the choosing of sampling locations, and the analysis of those samples. And so what is environmental DNA or eDNA? eDNA is a non-invasive technique to detect a species presence through the amplification of DNA found from an environment. My project utilizes quantitative polymerase chain reaction, which amplifies species-specific primer-probe sequences to detect a specific species. qPCR is sensitive to small amounts of DNA, which is crucial to the project as turtles shed less DNA than other organisms due to their keratinized skin, which limits them to only shedding DNA from bodily fluids like saliva, urine, and feces. As well, the sensitivity of qPCR makes it efficient for detecting rare or cryptic species, especially when compared to traditional methods of surveying. So in aquatic sources, DNA can be detectable for hours to days after being shed from an organism, but it still faces inhibiting factors such as downstream transport, flushing DNA out of the system, or degradation due to exposure to high pH levels, UV radiation, and higher temperatures. And then in soil, DNA can be detectable for decades to centuries, and this is due to reduced exposure to UV radiation and high temperatures in soil depths past 10 millimeters, but DNA in soil still faces inhibiting factors such as humic substrates and acids inhibiting Taq polymerase during analysis. As well, we were informed by DFO that repeated freezing and thawing can degrade DNA. So in areas that experience all 4 seasons, they would have a repeated freeze-thaw cycle every year, which could potentially inhibit the ability for DNA to be detectable for decades in soil systems. So now I'll be going over my two-eyed seeing methods I'll be going over my eDNA methods and my interview methods. So to collect aquatic eDNA samples, we use the Smith-Root eDNA machine and Smith-Root filters. The filters are connected to the machine and are held upstream from the surveyor, and they're held midway through the water column. And once ready, the machine will pump 2 liters of water through a filter. 3 filters are taken per site, and once completed, the filter is placed back into the bag in which it came in and is stored in an ice cooler for transportation until arriving at the lab, in which it's frozen at negative 20 degrees Celsius. I should also note that in 2024 and 2025, we use self-preserving filters, which can preserve DNA for up to 6 months at room temperature. So in 2024, we chose to store our filters in our office, which is temperature controlled at 20 degrees Celsius. And in 2025, we chose to freeze our filters instead at negative 20 degrees Celsius, which I'll get into later. And to collect soil samples, samples are taken from points of potential contact using a soil core, which extracts soils from depths of 0 to 15 centimeters. And points of potential contact include potential hibernaculums, potential nesting sites, and near the roots of alders. 1 core is taken per site, and that core is divided into 3 samples based on depth, typically between 0 to 5, 5 to 10, and 10 to 15 centimeters. Those samples are stored in whirl packs, which were chosen for their sterility, and then placed into an ice cooler for transportation and frozen in the lab at negative 20 degrees Celsius. As well, I should note that we only began taking soil samples in our 2025 field season. And so for our data analysis, we're analyzing for the presence of turtle DNA. So for a sample to have a positive detection, the DNA must successfully amplify, and if it does not, it's considered a negative detection. And for a successful amplification to happen, the DNA must surpass the limit of quantification and the limit of detection during analysis. And so for my interview methods, to collect Mi'kmaq knowledge, I'll be conducting interviews with Mi'kmaq elders and knowledge holders. And these interviews will follow the principles of OCAP, which has a strong emphasis on First Nations ownership and control over the knowledge that they choose to share with us. These interviews will focus on turtle behaviors and dynamics, as well as habitat changes or alterations that may have affected those populations. And so for our preliminary results, previously, the lab that I work with, GINU, did not have the equipment to analyze our samples. So our samples from the 2024 season were sent to the Center for Environmental Genomics Applications. So they analyzed our samples from our 71 aquatic sites in 2024. As well in 2025, these ones have not been analyzed yet, but we had 25 aquatic samples or aquatic sites and 21 soil sites. And so of the 71 aquatic sites, the majority of our results have come back negative, except for one of our wood turtle positive control sites having 2 of the 3 replicates be positive detections. And so we were informed by the Center for Environmental Genomics Applications that there was not enough DNA in our filters to surpass the limit of detection and quantification. So reasons for this could be that typical inhibiting factors that I listed earlier, preventing the DNA from being detected. As well, with the positive control that we took that had the positive detections, we saw a turtle upstream from our eDNA sample location, which in contrast to our positive control that had a negative detection, we did not see any turtles at that location, but we were sampling on a stream with known Hibernaculus. So this indicates that while turtles may be in the stream, if you're not in the right location or sampling at the right time, you may not be able to detect a turtle's presence. As well, with our positive control that had the positive detections, where only 2 of the 3 replicates experienced positive detections, this could indicate that the amount of water filtered through a sample could affect the ability for DNA to be detected. I'm saying this as in a study by Roll, they found that when sampling for wood turtle eDNA, they found when filtering 2 liters of water through a filter, it was more successful than when they filtered only 1 liter. And the reason why I'm mentioning this is that our filters from the positive control site roughly had only 0.5 liters filtered through them due to silt and substrate clogging the filters. So that could have potentially inhibited that 3rd filter, as well as other filters that we've taken at different sites. Along with this, there are potential errors that can happen that can affect the ability for DNA to be detected, but our methodology and storage methods would prevent this, but I'll list them anyway. Those would be water being trapped in filters, degrading the DNA over time, the self-preserving filters experiencing temperature fluctuations or UV exposure, and repeated freezing and thawing, which is something, these are all things that we're going to continue to keep in mind and work to prevent in future sampling. So overall, there's many factors that can contribute to a filter experiencing a negative control. And so moving forward, the GINU lab will be, we now have the equipment to filter our own samples from the 2025 and 2026 season. And as well in the 2026 season, we've decided not to continue with our soil samples. And we will also be switching to regular filters rather than self-preserving filters, as we're already freezing our filters. And the reason we're freezing our filters is because it adds an added insurance that filters are not experiencing any temperature fluctuations or UV exposure. As well in the 2026 season, we will continue to prevent any errors that could affect sampling, as well as we'll be repeating our previous sites. Along with this, we'll be conducting interviews with Mi'kmaq elders and knowledge holders, and then after that, we'll analyze our results from our eDNA surveys and from our interviews. I'd also like to take a quick moment to acknowledge my lab members at the Sakupi Maui lab at UNB, the GINU team, the DNR team, and the Inquotum team for their continued support and help throughout my project, as well as MyTax and NSERC for funding the project. Any questions?
Wonderful. That was super cool to see. Yeah. Is there any questions? Okay, I think there is one in the chat here from Michelle. What information are you hoping to obtain through interviews? Can you elaborate a little on the OCAP principles?
So OCAP means ownership, control, access, and protection. The information that I'm hoping to get from interviews would be related to traditional knowledge if they choose to share it, as well as potentially if they saw any turtles in the area or if they had heard of anybody else seeing turtles in the area. As well, any habitat changes that may not have been recorded, but they remember happening, such as a wetland getting built upon or forestry happening in the area. And yes, stuff similar to that. And with the ownership or the OCAP principles, these are put in place to help protect Indigenous knowledge from being misused. So when a person is interviewed under an OCAP interview, it ensures that they know they have the ownership, control, and access to the information that they're sharing with people. So hypothetically, if I interviewed somebody, I would show them how I'm going to use the information and all of this, and I'd have them consent to that. And at any time during the process of the interview or after the interview, they could contact me afterwards and change how they would want the information to be used, or if they want me to stop using their information. Was there any more questions?
Looks like that might be it. But thank you for speaking. That's super cool presentation. So I guess we'll move on to the next presentation, which is by Kayla and Sophia.
Yes, okay. So you're gonna share the screen? Yeah. Can you guys see our slides? Oh, we're at the back. Oops. Okay. I'm able to see. Okay, and we can go. Hello, everybody. Thank you for having us here today. My name is Sophia Reid, and I am an undergraduate student at Memorial University of Newfoundland, Grenfell campus in environmental science biology.
And my name is Kayla Downey. I'm a fourth-year environmental science student at Grenfell campus as well. And our supervisor for this project was Dr. Sean Boyle.
And we would like to introduce or welcome you to Bogs, Boots, and Biology. So to start off, we'd like to do a quick overview of what we're going to talk to you about today. So we'll start with a quick introduction of anurans to Newfoundland, including the extant species. And then we'll talk about our objectives for our field season last summer, as well as our methods, including our ARU locations. And then we'll talk to you about our preliminary results and any plans for future research. So to start, all of the anurans in Newfoundland, with the exception of the green frogs, were introduced to the Corner Brook area, which, for anybody that doesn't know, is the west coast of the island. Green frogs were introduced accidentally around 1853, but on the Avalon Peninsula, which is where around St. John's is. Mink frogs are also accidentally introduced, and they were discovered on the island in 2001. Besides the accidental introductions, we also have 4 species which were purposely introduced between 1960 and 1967 by a person named James Buckle. This includes the wood frog, the western chorus frog, the northern leopard frog, and the American toad. Of these introduced species, only 4 still remain on the island, including the wood frog, the American toad, the mink frog, and the green frog. The western chorus frog and the northern leopard frog failed to establish a population. Here are some pictures of the frogs on the island. This is the wood frog, this is our mink frog, and this is our green frog. And here's our American toad. These are some maps got from iNaturalist that show the distribution of each anuran species across the island. As you can see in the top left, the American toad is pretty evenly distributed across Newfoundland, and the green frog is also pretty evenly distributed. the wood frog and the mink frog are more centralized in the west side of Newfoundland. So overall, there's been very little scientific collection and observation of the anurans on the island outside of some citizen science through iNaturalist, which does help to determine distributions throughout Newfoundland, but it doesn't provide us with a complete picture. Usually around once every 10 years, there's research done on anurans in Newfoundland. And here's a quick map of the distribution of green frog and mink frog on the western side of the island. As you can see, green frogs are more concentrated around Stephenville, while mink frogs are more concentrated around Corner Brook and Deer Lake area. So our main objectives for our field season last summer was to collect data because there's very little available. And this collection of data will allow us to estimate abundance on the island and quantify the distributions on the West Coast. And it also facilitates future research in Western Newfoundland. Less is known about the impact that anurans have on our native species because they're introduced. So this data provides like a baseline for understanding anuran populations in Newfoundland. And here's a photo of one of our sites. For our methods, we were doing acoustic surveys using acoustic recording units, also known as ARUs. There was 10 ARUs across Western Newfoundland, and they were set up to record for 1 hour before and after both dawn and dusk. And we also did 3-minute call surveys at each of our sites, which is where we would stand and listen for 3 minutes and record which species we could hear on a scale of 0 to 3, with 0 being no calls heard and 3 being overlapping calls. We also did visual encounter surveys where we visited our sites and we would walk across the sites and record and count how many of each species that we would see. And along with our visual encounter surveys, we had hobo temperature loggers set up, which recorded the temperature for each elevation at each site. And there was 10 hobos to go with the 10 ARUs. And here's a picture of a hobo temperature logger, and here's a photo of an ARU.
So in total, we surveyed 39 locations across the West Coast. Of those 39 locations, 10 sites were used for acoustic monitoring. They had elevation gradients from 10 to 330 meters in the Corner Brook, Deer Lake, and Stephenville regions. We chose wetland sites that were disturbed and undisturbed. For example, in Corner Brook region, the ARU sites were on wetlands with dense vegetation or near ponds in areas of moderate disturbances. In the Deer Lake region, the sites were near highways or industry, but had open areas with less vegetation. Lastly, we had 2 sites off the Trans-Canada Highway, where one was on an active logging road and the other was going through succession. And one site was a completely undisturbed wetland with a large pond. And in the pictures attached, there are the 10 locations where we had our acoustic monitoring units. Our results show that there was a moderate density of anurans. We counted 23.01 individuals per survey hour, and there was a total of 2,520 individuals that we counted during the field season. And as you can see, the number of anurans counted decreased over the summer, where May had the most toads with all anurans were present, but in August we only counted 1 toad. So for May, we want to see the distribution of anurans counted per survey hour, and it showed that toads had 31.85 individuals per survey hour, and all other species were below 1, with wood frog being the lowest at 0.43 individual survey hour. Because our field season was the start of collecting data for species distribution, It gives us a nice baseline of what to expect for future research in long-term monitoring, as well as undergraduate and graduate research in occupancy and detection modeling. It's also important to learn if anurans are impacting native species through food webs or in ecological communities across Newfoundland. We would like to thank our supporters for our 2025 field season, which include Memorial University, the NSERC USRA Award, as well as Hualpu First Nation, and for also allowing us to research anurans on traditional and ancestral lands of the Mi'kmaq and the Beothuk peoples. And we'd like to say a big thank you for listening to us today. And these are just some photos that we've taken during our field season. And if you have any questions for us, please let us know. Thank you.
Wonderful. That was great. I guess, does anybody have any questions? Looks like we have a hand up from Amanda.
Hi, this is such cool stuff. Thank you for sharing. I was just curious if any of this acoustic monitoring will be done, in future years to add to your data set.
Yes, I believe this coming summer we will be using acoustic monitoring in different locations across the West Coast to determine if there are any different species distribution between the anurans.
Very cool. The reason I ask is because I study wood frogs myself, and here in Ontario, which I believe has a bit of a warmer climate than you out east, the wood frogs are very loud when they breed, but they breed so early. I'm wondering if you're missing them by starting in April. So I was just curious if you had thought about your time frame for future years.
Yes, and that was one of the main issues, I think, when we started. So we started May 5th, and at the time we thought it was a good time to start, but it was also very cold. And we noticed that we didn't get a lot of data on wood frogs. So this coming field season, we will be going out and starting in mid-April.
We also still get snow in April.
Yes, we do.
Yes. Super fair. I will be going out myself in a couple of weeks, so best of luck this year.
Thank you.
There are a couple questions on the chat. I don't know if you want me to read them out to you or.
I think we can see them.
What protection bias between persons and race? For Spencer's question, I'm not really too sure on that one. For detection, so we just kind of went out and kind of randomly sampled onto the sites. And for the 3-minute survey, if that's what you're talking about, we just listened for anuran calls. And we just did random sampling to find out individuals that were like along ponds or in wetlands. That's what you mean.
Kind of in the wetlands, we go back and forth across in almost like a grid. If that makes sense. I'm not sure if that answers your question. Oh, thank you. Thanks, Sean.
All those observations and use of English to clear. What are your observations? So we haven't posted any of our initial observations to iNaturalist. We're compiling a data set currently, and we will be hopefully publishing that within the next couple of years with the undergrad and graduate students and determining species distribution there.
Sure, that's a question.
Are there any more questions?
Looks like that might be it, but you guys did a great job, so I'm excited to see more coming from your work, especially with some of the detection models. So that'll be great.
You. Thank you.
Okay, I
want to welcome back everyone to the last half of our presentations today for our conference. This is our lightning talk section. So we have 4 lightning talks over the next 20 minutes. There will be time at the end of all 4 presentations for everyone to ask questions. So those who are doing the lightning talks, I ask that you're ready so that when the first person before you is done, the next person can jump in pretty quickly right after that, so we stay on time. And I also wanted to acknowledge a comment made by Arthur in the chat about the power of iNaturalist. If you didn't get a chance to read it, please do, because I fully agree, and iNat is an incredible source of data. Okay, with that, Daphnée, are you ready?
Yes, I am.
Fabulous. All right, let's get you to share, and then I'll start the timer.
Awesome.
All right.
All right. Well, hello, everyone. I'm Daphnée, and I work with Jan Sorget-Groba at the University of Quebec in Outaouais. And today I want to talk about our new project of 5 years on the blending soil. All right. So we started in the last summer of 2025, and it will be ongoing until 2029. And we focus on the main population of blending turtle in Quebec, which is in Outaouais. And this project started because in 2021, we captured a total of 185 blending turtle, but only 13 of those were juveniles, and they were all over 5 years old. We did not capture any hatchlings, despite catching hatchlings and youngs of other species. So this raised some questions, whether the hatchlings did not like our hoop traps, if they used different habitats, or if there was a concern for the population's viability. So we built this project with 3 main objectives in mind. The first is to perform a viability analysis for the species in Outaouais. The second is to improve our knowledge of critical habitats distribution to better protect them. And our third objective is to assess if entropic nesting sites are ecological traps based on previous observations. And to do so, to reach these objectives, we divided the project into 4 legs, which I will talk a bit further. So our first part is capture, mark, recapture. To reach our first objective of a viability analysis, we have 4 secondary objectives, which is to estimate survival and death rates by size groups, estimate the population size, assess if new individuals are recruited, and create an interannual age pyramid. To do so, we put baited hoop traps in the same wetland every year for May and June. And when an individual is captured, we mark and measure them among other manipulations. Our second leg is the monitoring of entropic nest sites. For our first main objective, we want to estimate the reproductive success and the predation rates in entropic sites. And this will help us assess if they are ecological traps when compared to non-entropic sites. We also want to assess nesting site characteristic and document nesting site behaviors. So to do so, we monitor nesting sites. We have 2 nesting sites, large sand pits, that we monitor for every evening in June. And we need volunteers to cover those large areas. So during these monitoring, the behavior is documented. The nests are protected when possible. And when depredation occurs, we document the depredation type, the predator if possible, the number of eggs, etc. And in August, we come back to assess the success, which is my favorite part. Our third leg is the telemetry tracking of females. To estimate the reproductive success and depredation rate in non-entropic sites, to assess nesting site characteristics, find nesting sites outside known ones if they exist, and understand habitat usage. Every year, we aim to follow up to 30 females with VHF transmitter in the afternoon and evenings of June until they nest and go back to their wetland, or until the end of the period if they do not leave the wetland. And finally, we will do the telemetry tracking of youngs to estimate the survival rates and understand habitat usage, and hopefully answer the question as to why we do not capture them. So our first cohort will be released in June 2026. They will be individual reared at Biodome of Montreal for 2 years that were taken from the nesting site that we surveyed and will be released in the nearby wetland. And we hope to do the tracking of up to 15 youngs. So this project will guide the management effort where they are most needed to assess if human intervention is necessary at all, and if yes, which stage is more vulnerable and which the effort should be focused on. So if you have any tips, if you've done this before, if you have any question or if you want to volunteer, please contact me. Thank you.
Fabulous. Thank you so much, Daphnée. Again, we will have questions at the end. So Christie, you are up. Make sure that you're unmuted before we start.
There we go. Yep. Okay. So, hello. Today, I just kind of wanted to present on some limb abnormalities I observed in 2 populations of the long-toed salamander during my surveys last spring. And so in 2025, I was in southwestern Alberta conducting fieldwork for my master's and other projects in the lab. This region is within the Rocky Mountains and specifically within protected areas, including both provincial and national parks. This area is along the eastern range edge for the long-toed salamander, which is a species of concern in Alberta. We were specifically targeting the adult life stage of long-toed salamanders at both sites. So the first site is in Waterton Lakes National Park, where I am conducting intensive sampling to resurvey a specific population. We conducted surveys on 60 nights between late March and early June, relying on both active visual surveys and a pitfall trap and drift fence system. The second site is approximately 50 kilometers away in Castle Provincial Park. We sample at this site on a yearly basis as part of a disease monitoring program. So we conducted 2 days of minnow trapping in May. And for both of these populations, I took photographs of all individuals for identification of recaptures, as dorsal stripe patterns are stable and unique in adults, and for morphometric analyses. And so to get started, I wanted to show the normal limb and digit morphology in the species for anyone unfamiliar with salamanders. There are 4 digits on the forelimbs and 5 digits on the hind limbs. And note that the 4th digit on the hind limb is elongated, hence the name long-toed salamander. So in Waterton, we captured a total of 43 individuals in 2025, primarily females. We observed 3 cases of polydactyly, which is the presence of an extra digit. 2 cases were on the 4th hind limb, and 1 was on the forelimb. The abnormalities were unilateral, so on one side of the body only, and all 3 individuals were adult females. We also observed 2 other abnormalities, also in adult females. The abnormality on the left is likely in the process of regeneration following a predation event, although we cannot say for sure. And then on the right is 2 views of the same tail, and we kind of see almost a split tail. And to note, we didn't observe any abnormalities during our surveys in 2024 of this population, though we did capture far fewer individuals that year. At Castle, we captured 12 individual adults, primarily males. Here we observed syndactyly, which is fused digits of 2 males. 1 abnormality was on the hind limb, and 1 was on the forelimb, and both cases were again unilateral. You may also notice that the dorsal stripe of these individuals is a lot more olive compared to the Waterton individuals, which is common for these 2 populations, and the dorsal stripe phenotype varies across the range. And so to kind of wrap things up, we didn't observe any obvious impacts on individual fitness, as individuals had comparable lengths and weights to the rest of the population. We also don't know what caused the abnormalities, as they can arise from environmental pollution, trematode infections, or abnormal regeneration following injury. The Waterton site is near a road, and so runoff could be a concern, but otherwise both sites are in relatively clean environments. We did observe a slightly higher rate of abnormalities than typical for other species in the literature, but we did capture a fairly small sample size, so we can't make any definitive conclusions there. But ultimately, I want to encourage reporting of abnormality rates so that we have a better understanding of baseline rates and any possible temporal trends. And I also encourage photographing individuals captured during studies, as you never know what kind of useful data can be gathered, especially in long-term data sets. And so finally, I just wanted to acknowledge all those who have supported my research, as this is just one sort of interesting observation coming from a larger project. And that's what I have.
Fantastic. Thank you, Christie. Okay, moving along, we have Amanda. When you have your screen up and running and you're unmuted, I will start the timer for you.
Thank you very much. Just getting set up here. Wonderful. Good afternoon or morning for everyone. My name is Amanda, and I am a PhD candidate at the University of Guelph. And I'll be sharing some of the lessons that I've learned over the past 2 years about raising wood frogs in the laboratory. So my PhD is about assessing the impact of natural gas industry pollutants on Canadian amphibians. And in the ecotoxicology field, there is new interest in gathering data on amphibians in general, but here at home, Canadian regulators and consulting companies are interested in gathering data on local species. However, the recent publication by Environment and Climate Change Canada on toxicity test methods for northern leopard frogs is really our only standard information on raising Canadian amphibians in the lab at the moment. So I just wanted to share my experiences of doing something like this in case it's helpful to anyone else. So I began my PhD in 2024, and the actual tests we were running are not that important for this story, but to give you a little bit of context about what we were doing, our goal was to perform 2 acute toxicity tests early in life on wood frog embryos and hatchlings, followed by a very long period in clean water all the way until metamorphosis. And here's an example of my setup. We started our 2024 experiments shortly before the ECCC guideline for northern leopard frogs came out. So we didn't have their recommendations, but we did use a feeding regimen that's commonly used by hobbyists. So that's softened leafy greens. And it's basically just boiled lettuce and spinach for 30 minutes. And you just plop it in the tanks, and you can see from the image that the tadpoles just go nuts for it. And we had great success with this, about 77% survival in our control tanks, and the toxicity tests went off without a hitch. However, this is very time consuming. Plus, surprisingly, romaine lettuce is very stinky when you boil it. So we had to do it either on my personal barbecue at home or in the fume hood in the lab. Then the ECCC northern leopard frog test method was published, and they had some suggestions, including using kale. So we added that to our little salad medley. And they also have 2 recommendations for softening the greens, either cooking by boiling or steaming like we've done, or purchasing the greens frozen and then thawing them, at which point they're very soft. And we thought that second idea was a great option to cut down on time spent preparing food. So we decided to try it in 2025. And in 2025, our experiments were very similar to the acute ones we did in 2024, except that we were going to conduct a 6-week-long chronic test, again followed by clean water until metamorphosis. And we were using our frozen and then thawed approach. However, shortly after we began feeding tadpoles, we noticed that they weren't doing well, and not just in our toxicity treatment groups, but we had very high mortality in control. And when we looked closer, we saw fungal growth on the food. So we got rid of it all, got rid of the bags we were using, used new bags of food, tried to clean the tanks best we could without interrupting the waterborne toxicity test. But the problem continued. And unfortunately, the mortality in our control tanks was so high that it invalidated our test. We only had 35% survival after just 2 weeks, and we had to terminate the test completely. Unfortunately, due to the very short explosive wood frog breeding season, we also couldn't collect more eggs to do another wood frog test that year. However, we were also conducting a pilot study about raising tadpoles on sediment. So we decided we'd keep it going and switch back to boiling food. And once we did and eliminated any fungus in the tanks, the death rate reduced by fourfold. And we were actually able to raise these individuals through to being juveniles. Later on, we also did an American toad test and boiled the food from the beginning, and we had 100% survival in those controls. So after all of that experience, I really recommend boiling greens for at least 30 minutes and avoid potentially losing an entire year of PhD data. So I hope that's helpful to anyone looking to do stuff in the lab with animals. Thank you.
Awesome. Thank you so much. And then last but absolutely not least, we have Jackie finishing off our 5-minute lightning talk before we go into questions.
Sounds good. I'm just getting the screen on. Can everyone, you can see it? Okay.
We can see it.
All right, sounds good. And I'm ready. Okay, so let's get right into nicknamed the amphibian doomsday disease. Chytridiomycosis has been described as the worst disease recorded among vertebrates in terms of its impact on biodiversity. Behind this devastating disease are two pathogens, Batrachochytrium dendrobatitis and Batrachochytrium salamandrivorans. They both have aquatic zoospore life stages where they will swim around attached to amphibian skin, where they will carry out their life cycle. And as you can imagine, that is incredibly disruptive to vital functions that amphibians rely on, which can result in mortality. Immunity against these pathogens can also vary a lot across species or populations. Luckily, we've got a robust BD and BSAL surveillance footprint here in the mainland Canada and the US. This work would not have been possible without collaborations between government agencies, NGOs, institutions. And if you're familiar with the chytrid work in North America, you may have also heard of the BSAL task force. So when we further evaluate this map, we can see that there's a clear data gap, especially in central Canada. Previous survey efforts in the regions are unknown. So please, if you know someone who has or is currently working on the chytrid research in Manitoba, please connect them to me. The more of us, the better. Or if you just wanted to talk about this miserable disease, feel free to reach out and we can chat. So I want to know two things. What are the implications of using continental scale data to guide regional surveillance here in Manitoba, particularly regarding environmental drivers? Is Manitoba environmentally represented across the continental dataset? And of course, I want to know what the prevalence of chytrid pathogens are here in Manitoba. My first objective is to visualize and quantify habitat suitability with species distribution modeling via the maximum entropy algorithm. So there are 4 phases to my modeling workflow. Phases 1 and 2 are just about gathering my inputs, presence points, predictors, sample bias settings, and then assembling them into a total of 18 treatments. However, the most important steps are in the last 2 phases. Models will be rigorously screened twice and then evaluated for extrapolation and transferability. If the performance standards aren't met during the modeling phase, indicated by the red line, then back to the drawing board I go. So I do have some data available. Meta-analyses showed an extremely negligible extrapolation proportion. And in terms of transferability, the median Manitoba average pixel cell values were well represented within the continental training domain. Both results are exactly what I was hoping to see, but we're not anywhere near done. So there are many ways that citizen science has helped my project, and this is one example. So the map that on the left was created by overlaying iNaturalist data on a threshold suitability map which may help us determine priority surveillance sites based on where species have been observed. Keeping observer and detection bias in mind, the key is to interpret these maps as nothing more than just raw amphibian presence in suitable BD habitats. So my second objective is to determine kitchen prevalence and collect field level ecology level here at in Manitoba. So I'll be teaming up with the SNAPS program and the Canadian Wildlife Health Cooperative for swabbing protocols and testing. I'll also be conducting microclimate analyses and looking at habitat quality, water quality, and anthropogenic disturbances. For all metrics that I ever ran, I want to quantify how sensitive model performances metrics are to the inputs using a two-way ANOVA and Kruskal-Wallis test. So hopefully that's the next step that I'll be going into. And for field work, we are currently in the early stages of site selection. So based on minimal extrapolation, strong consensus among model treatments and environmental representativeness paired with favorable metrics, it appears that continental scale data can help inform regional BD surveillance here in Manitoba. Citizen science and collaboration are essential to disease surveillance and awareness. And on a final note, our planet is changing rapidly and we may never truly know how chytrid pathogens will continue to impact amphibians and ecosystems. This is why continued long-term monitoring and surveillance efforts are critical. And I just want to thank my partners and thank you.
Thank you so much. That was fantastic.
Thank you.
Okay.
I'm just going to end sharing.
And with this now, we have 10 minutes here where we can ask questions to any of our four presenters. Roger, you okay to manage? I know there's some stuff in the chat.
Yes. Not 100% sure whether there was a question about whether the fungus was due to not boiling the greens. I guess that Michelle had.
Yes.
That was to do with the salamanders.
The wood frogs.
The wood
Yes.
frogs, right?
All good. We aren't entirely sure where it came from. We think that boiling the food is a good precautionary step. Yes, it takes some time, but just in case that the source is from the food, boiling is an extra precautionary step to reduce contamination. I didn't have time, but we're also, as another precaution, not going to collect our eggs from the same site we did last year, just in case it's an environmental origin. And the second part of that question was, can we communicate this to the Wood Frog Guidelines agency? Yes, I actually have a meeting later today with one of the people who worked on this method at ECCC, and I'll be mentioning it then.
Okay, and there are also comments by Arthur and Amanda with suggestions. I don't know if you saw that in terms of other things to feed. Yeah. Those are basically the questions I see, unless I'm missing them here.
Yeah, some of the questions were answered in the chat.
Yes.
And
Yeah.
we will make sure that all of those are summarized when we send out at the end of this as well, just in case it's not recorded. Does anyone have questions that they want to say out loud that wasn't put into the chat yet?
I have a question for Daphnée. Were you tracking the hatchlings? I think she said that she was maybe tracking hatchlings. And were you putting radio tags on them?
We want to do that for this summer. We haven't started yet. Yeah.
Right. Must be really small tags, I guess, right?
Yes. Yeah, very small.
Yeah. Okay. Yeah, I was just wondering, yeah, because we're doing some tracking this summer as well, but we can't use turtles under 200 grams. because of the technology we're using. So yeah.
Yeah, I have to double check as well the weight, but the turtles that we'll put emitters on are 2 years old, but they are the size of a 6-year-old because they did not go under full overwintering, so they grew larger.
Oh, right. Okay. And then all those hatchlings, you're not catching them in nets. You're getting them. You're hatching them yourselves.
Yeah, exactly.
Right.
Thanks.
Yeah, thanks.
Any other questions for our lightning talk presenters?
I have a question for Jackie. Do we see high amounts of death with the chytrid fungus in Canada? Like, is there population collapses like what we see in tropical anuran species?
Not to that extent, not that I know of. There's high prevalence here. Yes, there's quite a lot of prevalence here, but in terms of death, not quite. But it's really hard to make a general assumption regarding the immunity at a species levels, because sometimes within species and different populations, there's different different levels of susceptibility immunity. So sometimes it's the synergistic effects of the environment can have an effect on the pathogen prevalence. But pathogen prevalence is here. It's not as there's definitely death, but it's not as anywhere serious in the tropics just yet.
Right. And I guess the fact that we have a winter, like a cold season, does that also control the fungus? Because in the tropics, I think it thrives in like humid, hot conditions, right?
Yeah, so with the model that I've built here and with some previous literature, our temperate climate is actually very suitable, despite what you're seeing in the tropics. The only thing is BT has a hard time. They don't do well at extreme limits. So it could be the case that in the wintertime during hibernation season, they're all underground with the amphibians. So, they're sheltered away under the insular layer, so they're not as affected. But BD is persistent in the temperate regions. The cold doesn't seem to have an effect. It's more so the heat, the extreme heat that has the effect on amphibians. I know moisture and precipitation on both extremes also have a negative effect. So yeah, one end being too dry, on the other end, there could be some flushing away dilution effects. So you're probably not detecting it as much. So it varies sometimes. Yeah.
Right. Thanks.
Awesome. From Spencer, is anybody here working on projects in BC? Do you want to clarify what kind of projects? Like, are you referring to BD? We'll wait to see if you answer that in the chat. But any other questions for our lightning talk presenters before we close out? Okay, fantastic. So with that, I want to thank everyone so much for being here today and for taking the time to attend this year's virtual conference. As we close out the day, I'd like to return briefly to something that we acknowledged at the beginning of this conference, that although we are gathered here virtually, we are all joining from different places, from coast to coast to coast across Canada and beyond, on lands that have been stewarded by Indigenous peoples since time immemorial, and to thank those Indigenous communities who have and continue to care for the lands and waters. And these types of conferences just remind us that working across the landscape and protecting these species we care about requires collaboration, and the effective conservation depends on our ability to share knowledge, research, and on-the-ground experiences across regions and disciplines. And this need for collaboration is the reason that these events exist. So this event was organized entirely by volunteers through the CHS Meetings and Workshop Committee. Everyone involved in planning today's event has contributed their time and energy because they care deeply about this community and creating opportunities for us to come together in support of amphibians and reptiles in Canada. But all of this, the Canadian Herpetological Society, is only possible with the support of our members. So if you are not currently a CHS member, we strongly encourage you to consider joining. Membership fees directly support initiatives such as our in-person conference, student research and travel initiatives, and other opportunities that help bring our Canadian community together to support the next generation of herpetologists and conservation practitioners. And finally, thank you to all of our speakers, because we actually couldn't have a conference without you, and to our session chairs and everyone involved to help run this smoothly, and for all of your engagement and participation as an audience throughout our conference. I will be sending a follow-up feedback survey. I'll include summary notes of all of the information shared in the chat. There's been a lot of great discussion in there, and I want to make sure that we don't lose that information. And then I also hope that I get to see all of you at our future CHS events, whether it's virtual or in person, and I wish you a wonderful rest of the day.
Bye. Thank you.